everyone, in this video I'm going to show you how to draw beautiful electrical circuits using LaTeX. First, open your LaTeX editor. For my case it is Text Studio. Now open your new LaTeX document by pressing File and pressing New, or you can press Wizards and press Quick Start here, and you can set up your document style. I'm using the default here, and you can also set the margins, the left, right, and top and bottom margins. Then press OK. This is your new LaTeX document. It may be your journal, your thesis, or any document you want to include your circuit. Now save it. Write, for example, here, this is LaTeX. Run it, for example. This is my document. Now I'm going to include some electrical circuit here in my document. I will show you step by step how to do it. The section, the title, electrical circuit. And here, let's put my figure here, begin figure. Okay, let's run it again now. Put H here to place my figure right at the bottom of my text H. So here is the place where my circuit is to be included. Put here centering. I want to place my figure on the center of the page, and I want to give caption for my figure. Caption, the name my circuit. Let's say it my circuit. Here it is. Now let's draw a sample electrical circuit. Okay, to show you as an example, I'm going to include this electrical circuit to my LaTeX document. The first thing is mark important points. For example, I want this point to be 0, 0. And I want this vertical space to be 6 centimeter, 0, 6. So the unit from this point to this point is 6. Now, I have this point to be 0, 0, and this point to be 0, 6. Second, I want the distance from this to this point to be 5. So this is 5, and in the same vertical position, 6. Next, this is the same 5. This point is 5, 0. The midpoint, here the midpoint will be 5, 3. Next, I want this point to be, the distance from this to this to be 5 units again. Therefore, it is 10, 6. The last point is this one. This is again 10, 0. So, having those points, I'm going to draw my electrical circuit. So those points are important to position your circuit at a desired place. This is my choice of points, but you can choose any point that can make your circuit favorable to you. Any size, larger than this or smaller than this. You have a freedom to choose those points, but you need to choose logical points. To include my circuit here in my LaTeX environment, first, let's include an important LaTeX package called circuiTikz that can allow you to draw electrical circuits. So use package name here, circuiTikz, this one. Here, delete content, and let's draw here. This line from this point 06 to this voltage source V 200. First, begin circuiTikz here. Now draw coordinate 06 to V at a point 00, 0, semicolon here. Let's run it now. Let's use V capital V. As you can see, here we draw from 06 to this voltage source V, the European voltage source, and then 00 here. But this voltage source in American style is the more commonly used one. So let's place circuit is American. Let's use American symbols here. Now run it again. This is the American symbol for a voltage source. Let's complete this to 50 again. From 00 to 50. From this to this is a short wire. Draw a short wire here, short. Its end point is 50. Let's build it again. Oh, this is. Now from 06 here to 00 again 50. Now let's draw this part, this branch, the capacitor, and then the inductor, and then the capacitor. From 06 to 56, draw 0,62 capacitor C. Its end point is 5,6 is draw it. As you can see, it's correct. Now again from 2 inductor L, 5,3 to capacitor C, its end point is 5,0. Let's see it now. Oh, it's correct. Oh, it's complete this part. 5,6 to short line from 5,6 to 10,6, then a resistor from between 10,6 and 10,0, and short line again from 10,0 to 50. Draw from 5,6 to short 10,6 to resistor 10,0 to short line, and its end point is 50. Now let's run it again. We complete our circuit now. This is our complete circuit. The next part is assigning values and symbols for each circuit element: the voltage source, the inductor, the capacitor, and the resistor. So they need values or they need symbols to differentiate one from the other. Let's assign symbols or labels for each circuit element. For example, for our voltage source, let's give a name Vs. For example, here V, voltage source, label L equals Vs, V underscore S, enclosed in a dollar signs to indicate it is a symbol. So let's run it again. As you can see, we give a name for our voltage source Vs. So if you want this Vs to be to the left of the voltage source, so you can here place underscore L underscore, run it again. Yeah, it's placed in the left of the element or the voltage source. Similarly, let's give a name for our capacitor here, C1, for our inductor L1, for our second capacitor C2, for our resistor, R1, or R, simply R. Now let's run it. As you can see, every element is given a name now. But if I want again this C1 to the top of my capacitor, I can remove the underscore for C1. This underscore, I remove it and run again. As you can see, it is placed on the top of the element. So this way you can give names for your circuit elements. You can also change the type of your capacitor. You can make it polarized. For example, is a capacitor simply, or C. This is our commonly used capacitor. You can find this document or the circuiTikz manual from the homepage. You can download and read the manual to understand the circuit drawing mechanism correctly. So you can use a curved capacitor or polarized capacitor by writing C, small c, capital C, or writing curved capacitor fully. For example, let's write here in place of CC, write curved capacitor and run it. You can change it or make it polarized like this. Or you can write simply short form small c, capital C, and run it again. You can get similar symbol. So replace this by CC, small c, capital C again. So all the capacitors are polarized. So you can change your circuit element type like this. Now we have the circuit elements with their desired naming, but we may want also to give values, to assign values to each circuit element in addition to the symbols. So we may want, for example, the value for this Vs to be 12 volt. To do that, we add those values with the help of annotation. So with A equals 12 V, enclosed with dollar signs, so it overlaps. But to avoid that, we can move it to the right by a power superscript. Run it again. Okay, now it is placed to the right. In addition to that, we can include here a package called use package SI units. And here we can use \SI, here a value 12, and another plus a unit volt here. Remove this, our previous one, run it again. Yeah, it runs correctly and with displays a correct value, 12 volt. So our voltage source Vs is 12 volt. Similarly, we can give values for our capacitor, for example, C1, 2 farad, for example, CC, here, SI, 2 farad. It overlaps, so remove this, right, place below. For our inductor, let's say it SI, 4 milli Henry. Yeah, for our capacitor, copy C, let's say it microfarad. Why? Yeah, this brass must be, we add annotation, our superscript, and move it to the right. For our resistor, comma, equals to or 6 ohm, kilo ohm, omega. Oh, I forget the brass. So in this way, we can also add values for each of our circuit elements. You can add your circuit fully informative. For example, you can add the currents of each loop. For example, the current through this branch, I1, let's say it I1 in this direction. So find this branch from this point to this point you're drawing, the capacitor C1 here, and comma, I, small I, equals, in a closed with dollar sign I1. Let's run it. Yeah. So we include the current I1 in this direction by including this. Similarly, we can add the current through each branch. Through this branch, the inductor L1, the current through inductor L1. Here, place comma here, and add I2. Similarly, the current through this resistor, find a short here, and place comma here, and add current I3. Now let's run it again. So we have the currents I1, I2, I3. You can make your voltage source Vs sinusoidal by simply adding small s here, run it. You can add a node here, for example, by adding C1 here, comma here, and so this node. You draw a capacitor by from this node to this node. You can remove this node by removing this one and run it again. So we add a node. So you can add any node where you want. You can also add a symbol for a voltage drop on a particular circuit element. For example, we can add a voltage drop VR here with a desired polarity. For example, let's add a voltage VR, comma here, small v equals, enclosed with dollar sign VR, capital V underscore capital. I can remove this label in this annotation and with a dollar sign here with superscript, a power superscript. Now here it is. We have a resistor of 6 ohm with a voltage drop VR. So in this way, you can add more features to your circuit and make your circuit more fancy. You can draw any circuit and include to your LaTeX document in this way. Let's show you the PDF format of our LaTeX document just we prepared now. This is, see how it looks fancy, it looks beautiful. So in this way, it's better to include or draw circuits within the LaTeX environment and make your document more beautiful and more formal.
Okay, thanks for watching. Don't forget to like this video and subscribe the channel. Feel free to leave your comment.